different type of examples, simple examples. And any doubts still here? Anyone? Any doubts still here? Suppose I am going to run this program and I will show you how the statements will be printed and see here how the table is getting here. For coverage report it is. And here how the statements are giving in a table and line by line statement. Test is pass here and value of A, value of B and value of sum. It's an addition operation. Okay. And a UVM report summary. Report counts by severity. How many info statements are there? Total number of info statements and how many UVM warnings are there? UVM error, UVM fatal, everything it will be counted and it will be printed here. All the statements will be counted and it will display all info statements. These all are info statements for every test. So like that. Okay. In a tree model like that we can print in any model. Clear till here?
So in reporting
Okay.
mechanism,
Yeah, go ahead, Pranay.
yeah. So in reporting mechanism, do we have only 4 macros? I mean, like fatal error, warning, info.
Yes.
So other than that, any macros are there?
Only these UVM info, UVM warning, UVM print and fatal.
Only 4 macros.
Yes.
Okay.
In system Verilog, we'll have dollar monitor, dollar display. All those things will not be there here.
And
Next.
while we are declaring the packages, like we are writing the format like .sv and .svh. So what are the dot formats? What is .sv and .svh?
Dot sv just dot svh in the sense a header file. It represents as a header file. Dot sv for every file we will put it with a dot sv only. Even in system verilog or UVM we will include with a dot sv only, not as a dot UVM. SVH in the sense that it's just a header file.
I mean, SV means system Verilog.
Yeah, system verilog.
Okay.
Next, UVM transaction. In UVM transaction, what is the flow? First of all, UVM transaction is a component in that we'll have particular number of sequences. UVM transaction also called as sequence items, whatever the variables present in that. So we'll declare the common UVM, common sequence items from UVM sequence item. Those will be passed to the UVM sequencer. From sequence to sequencer. Sequencer is a mediator. Suppose this is a sequencer. Sequencer is a mediator between the driver and also sequence. Here in test level we have the sequence. In sequencer we have number of sequence items which are get randomized. Those sequences we need to send to the driver. To pass to the driver, in the middle we have the sequencer block. Okay, so sequence items are the transaction. Whatever the transaction data is there, those are the sequence item, the transactors. And in the sequence we do the randomization and we need to pass to the driver. Those will be passed by a sequencer. Sequencer is the router or mediator between the sequence and driver. Okay, so that's why here is the flow: UVM transaction, UVM sequence item to UVM sequence. Next, what is meant by UVM sequence? So start method, pre-body, body, post-body. Before session I told, right, whatever we are writing we are going to send to the driver, we need to write in the body method only. Body is the main method. Main functionality will be there in the body, like start the request or randomizing the data, passing to the driver, and request. Everything will be there in the body. Pre-body and post-body are the callback methods to add extra functionality. Okay. These are the examples. So UVM virtual task start, everything in UVM, everything we will write through virtual task, virtual functions only, mostly in all sequences or sequencer driver monitor, we use a virtual task. Okay, you already know what is meant by virtual task and why do we use overriding is possible mostly. And UVM sequencer base class sequencer start method. This is just start method. No need to worry. I can show you some example. So in the UVM sequence, this is what class name of the sequence is a add sequence extending from the UVM sequence, and as it is a parameterized class, we need to pass the parameter and object util and sequencer. This is just type of the sequencer. In sequencer, we have M type, P type sequencer. We'll discuss later. So in the virtual task main body, we didn't return pre-body and the post-body. You already know what is the difference between pre-randomized and post-randomized, right? Same as it is here, we have the pre-body and post-body. But pre-body, post-body, we need to call separately. Okay, but pre-randomized, post-randomized, those are automatically called. We don't need to call separately, but here we need to call. So request is equal to sequence item type ID create. We are creating the particular instance. So through that instance, a start item of request. So we are we are passing the request to the driver. Assert request dot randomize. So here all the transaction data, request in the sense transaction data, are going to be randomized, and finish item of request. That means driver will send these data. In the driver, we'll have this main run phase, right? So here sequence item dot port dot get next item of request. You if you see in TLM port, based on port or export, we use port implementation and get port, put port. Like that, here we'll have sequence item port dot get next item. Based on which type you're considering here, you need to write. And sequence item dot item done. Sequence item port dot item done. That means number of sequences completed, then it will pass item done. Got all the sequences. So that time the sequencer, the sequence will stop execution, stop driving the data to the driver. Like this, finish item. If pass the finish item to the driver, and driver will pass that item done. That means both side transactions are finished. Whatever the transactions are there, all are finished. Vinita joined now. Okay.
Yes, I join now.
Okay. So all the transactions are both side, it will check how many number of transactions are there, and it will give the signal as a item done. Okay. And this sequencer is just a routing mediator. We don't have any functionality further. Okay. So see here, sequencer. It specifies the sequencer on which the given sequence run. Okay. And next, UVM sequence methods, whatever I have shown now, create item, start item, finish item. So these are in the body, we write the start item, create, randomize, finish. These are compulsory. Okay, we need to follow these things exactly. The flow is same. If you don't want to write all these 4 steps, we have single step called a macro, UVM do macro. Tick UVM do of request. Okay, if you write that single macro, by default it will replace with all these request, 11th line, 12th line, 13th line, 14th line. All these things will be replaced with that UVM do macro. And also you may get the doubt, suppose if we use the constraints, inline constraints. For inline constraints, while we are doing the randomization, we will pass request.randomize with the something with address equal to something or add equal to some value. Like this we will pass. Okay. But how we can pass if we use do with macro? I mean UVM do macro. In that case, we need to use UVM do with macro. That means by default, we include the inline constraint UVM do with of request. Directly we can write and it will replace all these 4 statements. Okay. So those are UVM sequence methods. And so these all objects. Okay. Coming to the components. What are the UVM components? You already know. Monitor, driver, agent. Okay. So this component class is a quasi-static in nature and object creation is not allowed after build phase. Before build phase only, we need to create the object and we need to create the components. Key functionality provided by UVM component classes are phasing, first phases, execution control, hierarchy information, configuration methods. We need to write the configuration DB database and factory convenience methods and hierarchical reporting control. Okay, that means all from top to bottom we can report all the statements by using reporting mechanism. Next, UVM component. What are the different components are there and how the execution? So agent, UVM root, UVM environment, driver, UVM sequencer. Sequencer is also a component only. Sequence and sequence item to our objects, remaining all are components. UVM monitor, UVM test, UVM scoreboard, UVM subscriber. All these are components only. Okay. So how do we write the component? Class, my component, or any name like based on adder, you can use as an add component or subtraction component, whatever. My component extending from the UVM component. No need to pass any parameters. Why? Because all components are non-parameterized. And next, registering macro, tick UVM component utils my component and function new function constructor and class. Okay. Next, same. However, we write here for driver. However, we write class driver extends UVM driver and UVM component utils virtual method, virtual interface, and constructor build phase. Like that, monitor also same. UVM class monitor extends UVM monitor virtual interface because the connection and component utils macro. Here we are using analysis port from monitor to number of components will connect, right? So that's why we are using analysis port. Okay. So to design this entire test bench, first of all, we need to learn individually all the concepts properly. So then only we can design entire UVM test bench. Okay. So that's why every concept is important only. We cannot skip any concept in UVM. Okay, like phases or TLM ports or configuration DB, virtual sequences or sequencers, reporting mechanism. Every concept is important line to line. Okay, otherwise you will be getting lot of errors if you skip anything, even how to create the object or how to create the class. Even if you miss the utils macro, there also you will be getting error. Okay, so you cannot skip any topic. Next, UVM root and top. UVM first one is a UVM root, then only we'll get UVM top or UVM void. These are the hierarchy. Okay, so UVM root class serves as the implicity top level and phase controller for all UVM components. That is the main root component for all. And UVM automatically creates a single instance of UVM root called UVM top. UVM top manages phasing for all UVM components. Everything will be included in the UVM top because there only we include the environment or interface, everything, right? So UVM top can be globally configured, report verbosity. We have verbosity levels in UVM. Verbosity levels means before you have seen, right? UVM default, UVM medium, low, high. That means priority. So if you see here, UVM default we kept. Like that, we'll put UVM high, UVM low, or UVM medium. That means we are giving a priority of every statement. High means those will be high priority. Those statements will be printed first. Medium means it's just compared to high priority, just less priority. Okay. Low means very less priority. Okay. After all the required statements, then only we can print. So that is what the priority we will mention for UVM low, medium, or high. That's what we call as a verbosity levels. Okay, so we globally configure the report verbosity and as a global reporter. And next, features of UVM root. Following are the few methods and variables defined inside UVM root. Run test. Okay, run test phases all the components through all the register phases. Test name can be passed as an argument or can be part of command line argument. That means plus UVM test name, we need to provide the test name that equal to test name. Here run test, suppose that is a test name. String top levels, just top level components we need to include here, created by UVM run test. And print topology. In print we use various models, right? So here we are using print topology. So it will be print in a hierarchical way like that. Okay. So these all are basic components, how to create the object and components. Everyone understood the flow of creating object and components? Everyone clear?
Yes.
Any doubts till here? Revise, go through the recorded session and revise 1 or 2 times. I already shared the PDF, right? So you can revise the concepts. Okay, then only you can remember everything clearly. Okay, in one time we won't get all the concepts. Okay, next UVM factory concept. So I think you already got what is meant by UVM factory. Better UVM factory we will discuss in the coming session because actual sessions are starting from Feb 1st, right? So I want to start all these things from February 1st. Okay, so yeah, I will start from Saturday onwards all the concepts. Okay, because still there are few members going to join. Okay, so I will share you the recorded session of today's one and also this code adder. First, we will start with the adder code only, trying to understand everything through adder first 10 to 20 days, and then we'll go with some counter program in UVM or any register program. Finally, we will discuss with the AXI VIP. Okay, so we'll try to verify AXI VIP. So you will get clarity, UVM full-fledged clarity. Okay, so that's it for today's session. Mostly from Saturday, we will be having the session till 1.5 hour to 2 hours also maybe. Okay, so everyone try to revise this basic concept till then.
Ma'am, small doubt.
Yeah,
Can you please go back to that code just now?
this code.
Yeah. I have small doubt in this line number 11, 12. Like, what exactly is the difference between that
This one, huh?
function events? Yeah.
Okay. Did you know system Verilog?
Yeah, ma'am, basics and
Basics. Okay. In system Verilog, when we create the generator or driver, we use this constructor. Do you know why we use this constructor in system Verilog? This function new. Here, whatever the class generator we have created, to the class we need to allocate the memory. Okay, to allocate the memory, we are using the function new constructor here. We call it as a constructor. While we are creating this, if you see mailbox G2D, only mailbox is passing here for generator. But if you see in driver, class driver, in this class driver, we are here there is a constructor. That means creating the class driver. And here we are passing two arguments. One is a virtual FIFO, one is a mailbox. Why? Because in system Verilog architecture, generator, driver, and there will be a DUT. Generator pass the data from mailbox to driver, and driver send the DUT send to the DUT via interface, via virtual interface. Okay, so if you observe here, while we are connecting the generator, how many connections are there to the generator? Only one connection, that's what we call mailbox. But for driver we have two connections, one is a mailbox, one is a virtual interface. Okay, at the same time for for monitor also we have two connections, one is this virtual interface and one is a score to scoreboard we pass the data via mailbox, right? So two connections for the monitor, and for scoreboard also we have only one connection, that is a mailbox here. Okay, so while we are allocating the memory to the driver, we pass the two arguments, virtual interface and mailbox to driver, and also monitor. See here, monitor. For monitor also we pass virtual interface and mailbox, but for scoreboard only mailbox, and for generator only mailbox. Okay, so this is how we create the class. Do you know why we are using this keyword here?
uh, if there are multiple methods, so this represents this is calling from this local class.
Okay. So here mailbox G2D is created. G2D is the instance of mailbox. So here within the class, we are accessing same variable. If you use different variable, then we no need to use this. Okay. Directly we can assign, suppose A is equal to G2D. A is a different variable. Directly we can take the data type and just use. But here we are passing G2D to G2D. That's why without confusion to the internal compiler, we are just using this dot G2D to G2D. Okay,
So
same
one
here
dot,
also.
ma'am.
Mm.
So in that, if you go back to that line, G2D dot G2D, yeah, so that 11th line, this dot G2D, that left-hand side G2D belongs to the argument which has been created in 10th function, 10th line, or
Yes.
else it is in 8th line.
This one is newly created. Whatever we created here, that represents here, because this mailbox, to this mailbox we pass the value. This value is equal to right hand side.
Yeah, got it.
This one newly created. Whatever the argument we pass from outside the class to this constructor, that value will be assigned to this G2D. This value will be assigned to left hand side G2D.
Yeah, got it.
Okay, so here to create the class, to allocate the memory to the class, we are using the function new constructor. Same here also, to allocate the memory to the class, we use function new constructor in UPM. Maybe you will confuse, then we are already creating, right, class, then why we are using this component utils. Component utils is also creating a class, right? You may ask. Component utils is not creating a class, it's just a factory registration to access the do hook methods. Not only do hook methods, remaining methods, copy, compare, clone, all the methods. Okay.
Yeah, ma'am, got it.
Any other doubts, others?
Prashanti, can we start working on some assignment, or it'll
Yeah.
take some more
No.
sessions to run?
Today, first of all, if you try to understand overview, I can share you the assignment. See, in UVM assignments, in the sense, mostly by taking a example, we write the code. That is a good practice. So, did you try system verilog? Any example? By taking a design of Verilog. In system Verilog, we already designed using FIFO and 4-port calculator. Like that, you can take simple shift register, everyone.
Uh-huh.
Design system Verilog verification from scratch.
Okay. Shift
Yeah,
register. Okay.
yeah. Any or else I will share you the design today for any shift register.
Okay.
Okay, so if you
Mm-hmm.
design from
Mm-hmm.
scratch onwards, from scratch means what you need to understand. First, you need to understand the design. What are the input variables? What are the output variables? First, you need to write the interface. So interface, name of the interface, and declare a clock, reset, and all the input variables with the logic data type. Clocking block for driver, monitor, and write the mode port for driver, monitor. Okay, already I have given all these designs in the sheet. Okay, so you can refer the projects list, I think. If you refer everything, you can design from scratch. Okay, that is the best practice. Assignments, in the sense, I will give you the assignments also, but developing any design from scratch is a best practice. Okay, so first you need
Okay.
to design from interface. After interface, create the transaction class. After transaction, generator, driver, monitor, scoreboard. I think already Pranay doing this. He told to me. So you can also do, everyone start with the system verilog. No need to worry about a UVM. Once you get proper SV test bench creation, automatically you can able to do UVM test bench. Okay, as of now, no need to worry about the UVM test bench and assignments. Just learn about the theory topics. Concentrate on system verilog test bench development.
Okay.
Should we
Fine.
practice that with like coverage assertion concepts also, but or just the SV test bench?
See, coverage and assertions are extra additional things. First, you should get basic test bench development. Basic test bench development means just overall connection of environment, top level test bench. That basic is enough. Coverage and assertion, once we get proper output, everything is clear, then we can add coverage block or assertion block or any RAL model block, everything. Okay.
Okay.
Yeah.
Ma'am,
Okay.
which sheet you're talking about? Like since I joined recently, I didn't get any sheet or PDF you referred earlier.
Yeah, that is for regular students, not for you.
Okay.
Yeah, for you, UVM, I will share you the assignment. I will share all to all, but you also, whoever joined for workshop or anything, whoever new students are there, try to develop system verilog from scratch. I will give you the designs for you also. Okay, system verilog, any example I can provide you for FIFO. Okay, take the example of FIFO. Try to understand. I will share you the recorded session also for FIFO SV test bench. Okay. Even though you don't have any access, so try to develop from SV. Okay, then you can concentrate on Verilog. I mean UVM.
Okay.
Clear, everyone? Any doubts? But UVM concepts also important. I told you just concentrate on theory concepts as of now for UVM. Okay.
Okay, ma'am.
Okay. Okay then. Pranay, do you have any doubts? Gurishan, CB, Vishal, Kirti,
No.
Kartikeyan,
No, ma'am.
No, ma'am.
Vinitan, Sheetal.
No, ma'am.
Just
Okay.
you send the SV assignment so that we can write test bench
Yeah.
with that. Yeah, that's
Okay. Yeah, I will share it. Okay then.